Hi, and thank you for joining. Today we are going to go through the 8.03 Solutions Lab. This is the completion video. I will not be going through and completing the hands-on portion of the lab. However, we do have a video here at the top of our lab report template that is in the Student Help site. This video will help you with the pre-lab questions and analyze the data, and then do the conclusion and the post-lab questions. So by the end of watching this video and the one that you are currently on, you will have the lab completed. The information that we do need to have in order to complete this lab is a general understanding of molar mass from lesson 5.02, molarity, dilutions, and some general idea about solubility factors. Let's go through just a quick description and explanation of these. Molarity from 8.02 is one of the ways that we can express the concentration of a solution. Molarity, which we use a capital M to represent, is the number of moles of solute divided by liters of solution. As you can imagine, if you are given milliliters, you must convert milliliters to liters. Now, oftentimes in the lab, we don't know moles, we know the mass. And this is where the molar mass comes into play. Molar mass from lesson 5.02 is the mass in grams of 1 mole of your substance according to the periodic table. So you will use the periodic table, add up all the masses for however many atoms that you have in your compound, and that is the molar mass. We can convert mass to moles by dividing by that molar mass. An example is included here for you. Dilutions are exactly what we're going to be doing today. Dilutions are where we take a concentrated solution, we remove a small portion of it, put it into another container, and then add water. So we will dilute it or make it weaker. Oftentimes you will see it as M subscript S. So that's molarity of the stock or the molarity of the concentrated solution. V, volume, and then subscript S for the volume of the stock or the concentrated solution. When you multiply those two together, it will equal the total of mass, just kidding, the molarity of the diluted solution times the volume of the diluted solution. So you can see the values on the left are your initial or your starting solution. Oftentimes you may see instead of that subscript S, you might actually see the number 1 because it's the first one, it's what you're starting with. And then the second one is what typically you're solving for the second molarity. What is the new molarity? Depends on the question. It could ask you a multitude of things. So if you see it with numbers on the left-hand side, those S's could be 1s for the initial. And then on the right-hand side, those D's could be 2. So your first and then your second, your beginning and your final, your stock and your dilute. Now, an example of how this looks is your stock solution is very, very concentrated, which means it has a lot of moles, not a lot of volume. So if you had a concentrated solution of, let's say, lemonade, that is going to be very, very, very tart, depending on the sugar that you add in there. Could be sweet. Now, if you want to make it dilute, you're going to remove some of that lemonade. You're going to put it into another beaker. All right, so it has the same number of moles. But then we're going to add more water to it. We're going to, quote unquote, water it down. That's dilution, watering it down. And that's exactly what we're going to be doing today in the lab. In the lab, we are going to be taking the look at 3 different solubility factors, and we will get to that in just a moment. The pre-lab is an extremely important part because these values are what we need to do the hands-on portion of the lab. So if you do not do the pre-lab, when you watch the video of one of our teachers completing the lab, you're going to be confused as to where she got all those numbers from. So the first thing we want to do is calculate the molar mass of the drink mix. Now, it could be like a powdered drink mix, like tea, Kool-Aid, anything like that. It doesn't matter. We're just looking at the sucrose, that sugar. And that's what we're going to be focused on. So we do need to calculate the molar mass of this compound. So don't forget, molar mass is the mass in grams of 1 mole of your substance. So in here, we have 12 carbon atoms. So 12 times the molar mass on the periodic table. And then we have 22 times the molar mass of hydrogen, and then 11 times the molar mass of oxygen. Now remember, the molar masses, this is on the periodic table. And then whatever numbers you get here, you're going to add them up. All right, so right here, you're going to add them up. Whatever these 3 numbers are, add them up, and that's your molar mass of sucrose. All right, and then from there, we have to determine the mass. Because remember, when we're in the lab, we don't have a way to measure out moles. So we measure out mass, and then we use the molar mass to convert to moles. So we're going to determine the mass of the powdered drink mix. What we want to do is make 100 milliliters of a 1 molar solution. So my concentration, my molarity is 1 molar solution, and I know that I want to have 100 milliliters. Okay, so what we're going to do is we are going to plug in our values. So if we use this formula, all right, so molarity, well, the problem gave us molarity, right? Because it's 1 molar. So we're going to put that in over here, 1 molar solution. That's how we write it. I don't know the number of moles. Ooh, liters. Remember, we have 100 milliliters, so we need to convert that to liters. So 100 milliliters. And then we know that there are 1,000 milliliters in 1 liter. Whoops. So this is a fraction. I'm doing the best I can here. All right, so 1 liter divided by 1,000 milliliters, and that is going to equal your number of liters. So 100 milliliters divided by 1,000, that's how many liters. That number is going to go here. And now we have values of 2 of our variables. We can rearrange, solve for the number of moles. But the problem wants mass. Remember, once we get moles, let me scroll down a little bit. So question number of moles of solute, which is your sugar solution. And then we can multiply by the molar mass in number 1. And then that's going to be divided by 1 mole. All right, so your molar mass right here of your substance is what we calculated right here. Okay, so that's going to be the molar mass. So when you add these numbers up, whatever number that is, and you can imagine it's going to be large, that's your molar mass for here. So solve for number of moles, and then convert that moles to molar mass, or convert it to mass by using the molar mass, equals question mark grams solute. There you go. So that's a quick, easy way of how to do that. And then what mass of the powdered drink is needed to make a 0.5 molar solution that has 100 milliliters. So it is exactly what we did up here, except now we're going to have 0.5 molarity instead of 1. But you're going to go through the exact same problem. Okay, so you're going to have 0.5 this time. 0.5, so that's going to change the answer slightly. We still need to convert, or you can just look up here and figure out what the, the liters were. All right, and then once you get that, you can plug in your liters, okay, solve for your moles, and then convert moles to grams using the exact same molar mass because it's the same compound. All right, now let's move on into our data. In our data, we are going to use the teacher's video that has already been made, and we're going to record her data into our data table. Notice that it is set up based upon 3 different solubility factors. The first factor is temperature, and then we have agitation, and then particle size. So with temperature, we are going to use both molarities, 1 molar solution and then 0.5 molar solution, and we're going to not heat it up, and then we're going to monitor and record what the taste, texture, and color is. Now, of course, taste you guys cannot do because it's a video. However, she does a very great job of describing how it tastes. And then for temperature, we're going to have the same different concentrations, but now we're going to have with heat. And now we're going to go into agitation. Notice the same format, 1 molar concentration, and we are going to stir it. And then we're going to compare that to the 0.5 molar concentration, and we're going to stir it. Agitation, now we're going to do it without stirring it. So we're not going to agitate it. And finally, the particle size. So with this sugar, this is actually granulated sugar. We tried not to make the data table too congested. So the first 2 here are with granulated sugar, the small little pieces of sugar that are very hard to pick up if you spill on the counter. And then we're going to do it with sugar cubes, which are the larger blocks of sugar. So as you watch the video, go ahead and record what she says about the taste. Try to see the texture. She does describe it as well as the color. Now, I will say the color does appear quite similar throughout, but try to distinguish, is one more like a deeper color, or is it a little bit lighter, or, anything like that that you can. As far as the texture, try to be the best that you can in terms of, being descriptive. Think about if you're comparing one to the other. Definitely put in here that you watched the video as opposed to doing it on your own. So that way we know that your data is going to be matching hers. Now, every student describes it a tad bit different. Some include really great detail. All right.
So I'm setting all of this up for you. I have the cups labeled already with the 1.0 molarity and the different solubility factors, and the 0.5 molarity with the different solubility factors. I will also mix the tea mix according to the package for the control. From our pre-lab, we determined that in order to mix up 100 milliliters of a 1.0 molarity solution, we would need to add 34 grams of the drink mix and fill to 100 milliliters with water. Because I don't have a kitchen scale, 1 tablespoon is going to equal 12.5 grams and 1 teaspoon will equal 4 grams. So for the 100 ml of the 0.5 molar solution, it's going to be roughly half at 16 grams. We will test all 3 solubility factors for each molarity. We will not be testing the control solution. We just taste it and compare it with our 1.0 and 0.5 molarity. Our 3 solubility tests will be temperature. How does temperature affect solubility? We end up mixing a teaspoon of sugar into each room temperature tea and then a teaspoon of sugar into the heated tea. Agitation or stirring, how will that affect solubility and the taste? And finally, particle size. We will be using sugar cubes, which you've probably never seen, and just regular granulated sugar to see how that affects solubility. All right, let's get going.
So I think we have everything just about set up for our lab. I'm going to zoom in on a few things that we have here. So first of all, we're going to mix up the control, which is going to be exactly the way the drink mix package tells us that we need to mix it up. So right there on the drink mix package, it tells us that we're going to put about 2 1/4 teaspoons to 100 ml of water of the powder, and that's going to be about 9 grams. Then we're going to mix up a 1 molar solution. And now you notice that's a lot more powder, and we're going to end up with about 34 grams based on our calculations from the pre-lab, once again in 100 milliliters of water. And then the 0.5 molars is half of that, and that's going to be approximately 17 grams, so I measured that out, and we add that to 100 ml of water. I then poured 100 ml of each into the different solubility tests. So we have 1 molar with heat and without heat, 1 molar without stir and with stir, 1 molar with sugar cubes, and the same but with the 0.5 molar solution. So the first test, solubility test that we're going to do is we're going to take a teaspoon of sugar, it's a teaspoon, and we're going to put a teaspoon in each of the 100 ml, and this is the 1.0 molar concentration. So I'm not going to stir it because that's not part of our solubility test, but what I'm going to do is I'm going to leave this one alone and taste it without the heat, and then I'm going to heat this one up and taste it. All right, so the next thing, we're going to go ahead and put a teaspoon of sugar in the without stir and a teaspoon of sugar in the with stir. All right, so I'm going to have to stir the with stir. Stirring, stirring, stirring. Now I get to taste it. I can't say I'm looking forward to this, but for you guys, I will do it. All right, so this is the 1.0 molar with stir. I'm going to taste it. And that's sweet. Really sweet. Now this is a 1 molar without stir. It's really not as sweet, even though I put the same amount of sugar in both. All right, next is the 1.0 molar with sugar and the 1.0 molar with sugar cubes. So this would be particle size. Okay, this one was agitation, and this one would be particle size. All right, so here we go again. Teaspoon of sugar. And then a sugar cube, 1 cube is approximately a teaspoon. Okay, but I am not supposed to stir this. That's the thing, okay? You can't do 2 different solubility tests. So I'm going to go ahead and taste it. This is with the sugar. It's okay. It's a little sweet, but it's not too bad. And then this was with the sugar cube in it. It's not good, but it's definitely less sweet. Okay, so that concludes the 1.0 molar test. So we're going to do the same with the 0.5. Okay, so now it's time to do the 0.5 molar, which, if you remember, is half the concentration. We have the same solubility test with stir, without stir, and I already put the sugar in there just to save some time, but I'm going to go ahead and stir that. Taste them both real quick. Tastes more like tea instead of just sugar water. Tastes kind of bitter. Okay, the heat we will do last because I need to heat those up. This is the 0.5 with sugar, not stirred. Kind of bitter. And then this one with the sugar cubes. Yeah, at this point it's kind of hard to tell, but I can summarize all of this in a data table, which will be on one of the next slides. Let me go ahead and heat up the solubility test with and without heat. We'll test that, and then we'll summarize. All right, so this is our last test. These are with the heat. So I've got the 1 molar with and without heat and the 5 molar with and without heat. So I'm going to try the without heat first. And now the with heat. Tastes really different with the heat. I don't like it. It's very sweet and kind of weird tasting. All right, without the heat. And with the heat. And this is the half concentration. I guess some people might really like this if they like super sweet drinks. Me, I don't feel so good now, but I did it for you guys. So now we're going to go ahead and
conclusion. So the conclusion, we do want to make sure that we write in complete sentences. What is the purpose of the lab? What did you explore and what did you learn? Those are 3 separate parts to this point. Please make sure you address them all completely and thoroughly. And then what effects did temperature, agitation, and particle size have on solubility? Please indicate those separately. What effects did temperature have on solubility? When you heated it, when you didn't heat it. And then discuss how agitation, when you stirred it and when you didn't stir it, how did that affect the solubility? And then analyze particle size. What effect did that have on solubility? So there are 3 separate parts to this, not one long run-on sentence, okay? All right, and then just a quick statement now that you've talked about all 3 different solubility factors that we analyzed. Now we're going to look at it and see which one changed the mixture the most based on your data. Now please make sure you do include your data. Why do you say solubility factor X factor changed that mixture the most? And how did you know? And then same thing, but we're going to look at which one affected it the least. All right, and then the post-lab connection questions. Number 1, if you were working for a beverage company, which molarity would you recommend and which directions for mixing would you use to create your drink package? So what you want to do there is, there's 2 parts, which molarity and what are the directions. So would you, out of the ones that probably tasted the best, right? Which one changed the mixture the most? Perhaps you want to look at which one tasted the best. And again, I know you're not tasting it. You can go back on what she says in the video. All right, which molarity was the best? Perhaps it's which factor affected it the best. Which one did she say tasted the best? Was it the 1.0 molarity or was it the 0.5 molarity? And then which solubility factor? Okay, so make sure that you analyze, okay, include the molarity, 1.0 or 0.5, then include the directions, which is which solubility factor. So there's 2 parts, okay, in this. So look at the solubility factor and then just whip up a quick directions on how to make that solution. All right, and then finally, we are going to do the math for our dilution. So starting diluted, So what I recommend doing is having MS equals VS equals MD equals VD equals. Now remember, you can always think of it as first, last, initial, final. So how would you do it if you needed to make a 100 milliliter of a 0.2 molar solution from the 1 molar fruit drink solution? So when we say from, look at this. 1 molar, 0.2 molar. Which one is diluted? That's one that's the least concentrated. So our diluted is here. So I know my molarity of my diluted solution is going to be 0.2. And then I know I want to have 100 milliliters. And remember that we need to have liters, right? However, do we really have to convert to liters? Because whatever unit this is, that's going to give me the same unit. So do we need to convert? You can, and then you'll get a final volume in liters. However, for this one, we can't actually leave it to milliliters. And so it says, how would you do it if you needed to make 100 milliliters of a 0.2 molar solution drink from the 1 molar solution? And so right here, we're solving for this. So you can go ahead and plug and chug into this, rearrange to solve for your starting volume. And what this means is that you have a 1 molar solution, a concentrated solution sitting on your bench, on your desktop. And then you are going to go obtain this much of that solution. Okay, you're going to go get whatever milliliters this is. And then you're going to take that into a second beaker. You're going to place that volume in the second beaker, and then you're going to fill to 100 milliliters. So how much water do you need to add? Okay, so that's going to be the 100 milliliters minus the initial volume. All right, so your 100 milliliters, that's your final volume of your diluted. This is how much of your concentrated. So let's say it's 10 milliliters. Let's just say, okay, it's 10 milliliters. You're going to put 10 milliliters in the beaker, and then you're going to fill it to 100, which means you're adding 90 milliliters. The answer is not 10 milliliters. Don't worry about that. All right, guys. Well, with that, we are done with this lab. Thank you so much for joining. I really hope that you were able to understand this lab a little bit better. And so with that, we are going to submit your lab report. Now, this is the last lab of the semester of the course. So hopefully you already know how to analyze your lab report before you attach it. But just in case, make sure that you review and proofread all of your answers. Are they clear? Are they concise? Did you show all of your work? Did you include units? Are you detailed in your observations from the video? Or if you want to purchase the materials and do it yourself, that's fine too. Do your answers make sense to the reader? Name it whatever you want to name it. An example is 803 lab. Do not use file decimals in the file name. Make sure it's in a proper format and size. Mac users, please remember we cannot open pages, and Google users, we cannot use and accept links. You must download and attach a file. We always need the hard copy of your file, and student comments is just for that. Comments, not academic work. Go to your gradebook file, submit, add the DBA. Maybe next, I'm going to put maybe. Sometimes students save the labs for last, so possibly it's the next assignment. If it is, go ahead, reach out to your instructor, get that DBA scheduled. If you are working in order, you have just a few more assignments left and then the DBA. Don't wait. Please allow some time to schedule that DBA with your instructor, especially if a weekend's coming up. All right. And of course, the course resources, if you don't know, on occasion, I am a resource teacher, formerly referred to as lead teacher. So I cover a lot of classrooms when teachers are on vacations or out sick. And I will have students doing a Module 8 DBA and not know about the course help site. I'm like, how have you gotten here and not known about it? So I know some teachers give direct links to lab reports, so you may not have been in the help site, but just in case, on the announcement page, underneath your teacher's information, there's the course resources, and here's the course site, help site. It has all of this stuff in there. All right, we could actually delete everything in this little section because it's all in the help site. All right, guys, it was great working with y'all. I hope you have a great day, and good luck finishing the semester.